All right, so we're going to do another example of solving a DE with undetermined coefficients. And at the end of the last video, I kind of foreshadowed a little bit on this example, said that we're going to run into an issue doing this process the way we've been doing it so far. So the first part's going to be normal. We're going to start with that auxiliary equation. There's going to be no issue here. So the auxiliary equation in this case, we have y double prime plus 2y prime. That's going to turn into m squared plus 2m equals 0. This factors to m times m plus 2 equals 0, so we get solutions m equals 0 and negative 2. So this gives us a complementary solution, y c equals, so c1 e to the 0x is the same thing as e to the 0, which is just 1. So notice that this gives me a constant only, c1, plus c2 e to the negative 2x. Okay, nothing out of the ordinary there. That's just a normal process for getting that complementary solution. Now, what would be the natural choice for yp, for our particular solution? Well, it seems natural here, if we have a linear function, 2x plus 5, it seems natural to choose ax plus b then to match with that. And then we have e to the negative 2x here, so it seems also natural to use c e to the negative 2x in our particular solution. So we need y prime, we need y double prime, so I'm going to differentiate this. We have yp prime equals a minus 2c e to the negative 2x, and then yp double prime is going to equal 4c e to the negative 2x. Let's plug this in to our DE now. So I have y double prime plus 2y prime. What does that look like when I plug yp in for that? Y double prime is going to be 4c e to the negative 2x plus 2 times this guy. I made a little mistake. I scribbled that, but that should look like a minus 2c e to the negative 2x. And that should come out to 2x plus 5 minus e to the negative 2x. Now look at what happens here. When I distribute this 2 in, I'm going to get a 2a here, but then I'm also going to get a negative 4c e to the negative 2x, which will completely cancel with this guy. And that leaves me with this. 2a equals 2x plus 5 minus e to the negative 2x. That's a problem, okay? Because what we are saying here is that a constant function is equal to a linear function plus an exponential function. That's clearly false, right? There's no way this will ever equal this if that's just a constant and this is a function, a non-constant function of x. So what we have here is a contradiction. Okay, which means our original choice of yp was wrong. But how could we have anticipated that? Because we've followed the same logic as we have in the last 4 examples, and those all worked out fine. What's the issue with this? Well, the problem is that this function is already accounted for, or at least part of it is already accounted for in our complementary solution. Let's look at it in terms of its terms specifically. So for example, right here, c e to the negative 2x. Okay, that any constant times e to the negative 2x is going to be a solution to the homogeneous equation, the associated homogeneous equation. Basically what we're saying is if I choose c1 equals 0, and if I let c2 equal whatever this c turns out to be, then that shows that this term is a solution to, this term belongs to that set of solutions that we call the complementary solution. What that means is that if I plug this term into my DE up here, it should be coming out to 0. Not anything that resembles this. Similarly, we have a constant term showing up here, and among our linear function here, our linear expression that we chose, ax plus b, we also have a term that is a constant. And so that constant has been accounted for in the complementary solution. Once again, that's a problem, okay? So whenever you get terms in your choice of yp here that also show up amongst your complementary solution, it's going to lead you to a contradiction like this. And so we make a modification to the functions that we use for yp. Specifically, we multiply them by some power of x that eliminates that issue. So I'm going to do this. I'm going to cross this out because this led us nowhere good. And we're going to try again. Okay, yp equals. What I'm going to do is I'm going to look at the linear function, ax plus b, and I'm going to multiply that whole thing by x. Okay, if I multiply the whole thing by x, I end up with ax squared plus bx. Now compare, well, we're not done yet, but compare that to my, my complementary solution. This has an x squared term and an x term. My complementary solution has neither of those. So we should not run into that issue, at least as a result of these terms. Same thing with the exponential term also. Instead of saying plus ce to the negative 2x as one of my terms, I'm going to multiply that by x, kind of like what we do for reduction of order. And I'm going to say plus cx e to the negative 2x. Is the term I want to use. It turns out that by multiplying each of those expressions by x, we've resolved the issue that we ran into up here, and we'll be able to solve this thing now. So in order to do that, now I need my derivative. So yp prime is going to equal 2ax plus b. This guy here I'm going to need my product rule for, so that's going to turn into plus c e to the negative 2x minus 2cx e to the negative 2x, okay? Next up, what I'm going to need to do is differentiate this guy. That's going to give me yp prime equals 2a. This derivative of this is going to be negative 2c e to the negative 2x. Then if I differentiate this, again, I have to use the product rule, so I'm going to end up with negative 2c e to the negative 2x plus 4cx e to the negative 2x. And then I see where I have some combining of like terms that can take place here. So I have 2a minus 4c e to the negative 2x plus 4cx e to the negative 2x. Okay? That should be a double prime right there. Okay, so now I have a different set of functions that I can use in my DE up here. Let's try them out. I'm going to see if I can squeeze that in over here. I'm a little pressed for space. Y double prime, we're going to use this expression here, this function, 2a minus 4c e to the negative 2x plus 4cx e to the negative 2x plus 2 times yp prime, which is going to look like 2ax plus b plus c e to the negative 2x minus 2cx e to the negative 2x. Yikes, got really, really short on space there. And that should be equal to 2x plus 5 minus e to the negative 2x. That's my g of x from right here. Okay, simplify as much as possible. Let's go like this. That's going to give me what when I simplify it down? It should end up looking like, let's see, 4ax plus 2a plus 2b minus 2c e to the negative 2x, once again, equals 2x plus 5 minus e to the negative 2x. Okay, so what I'm doing here with these parentheses, notice I have a 2a here, and I'm going to get a 2b when I distribute that 2 in right there. But I'm grouping them up because I want to associate that with the constant term. And I'm going to be comparing that entire thing there with the 5 here when I'm trying to solve for these unknown coefficients. So let's now do our comparison, because this takes the same form as this. 4ax, compare the coefficient 4a to the coefficient 2 here. That would imply that a has to equal 1/2. Okay, I'm going to write that over here. So a equals 1/2. What about b? So again, I have my b here. If 2a plus 2b is supposed to equal 5, and if a equals 1/2, that's going to give me a 1 here, meaning b would have to be 2, so that I get 2 times 2 is 4, plus 1, that's 5. So b is going to equal 2. Finally, I can see that c would have to equal 1/2, because the negative 2 times 1/2 gives me the negative 1 that I need for that coefficient. c equals 1/2. And so now, notice I didn't run into any issues with contradictions or anything like that. I'm going to take my complementary solution, use the coefficients that I just found in my particular solution, and write my answer. Y equals c1 plus c2 e to the negative 2x plus 1/2 x squared plus 2x plus 1/2 x e to the negative 2x. This would be my final solution. Again, there's my complementary solution, there's my particular solution right there.